Alright, I thought that I would make a video series about power supplies. There's really not a lot of videos out there about making custom power supplies, apart from the great Dave Jones at the EEV blog. That series I watched and I was kind of inspired by it, just to get into the hobby and do this kind of stuff. But I thought I'd kind of share what I'm learning because it's fun. Keep in mind, I am no EE, I'm no PE, I got no FE, got no E's, man. So, anyways, I'm just a lowly HVAC controls technician. So keep that in mind. I'm not a professional at this. So just remember that as we go through this. I'm just doing this for fun and to pretty much just document what I learn. If you find it helpful, go ahead and give me a like. Anyways, let's start with Dave's circuit. You can look that up, watch his videos. He does a phenomenal job at describing what he's doing. I wanted to start with this, the LT3080, which is what he uses. I don't know. You also got to remember here that I'm not one of those people on the boards posting whatever. I don't think I know everything, and I don't think I'm all that. There are those that think that they're all that, and there are those that are actually all that. And the difference is this, that people who think they're all that will just criticize something. And there's a lot of that going on with Dave's circuit for his power supply. Whatever. It's helpful. It is still helpful. But what's even more helpful is to suggest an alternative or to describe why and maybe something that's better. Because guys like me, I don't know. I don't know. This isn't a finished product. This isn't going to be sold or anything like that. So just keep that in mind. If there's better ways to do things, tell me down below. But you also have to remember that the circuit that I'm going to be putting together in this is not meant to be perfect. It's meant to help me learn stuff. That's what I'm all about. I just want to learn more. There's going to be design choices where you're just like, that was so stupid. Well, I'm trying to learn about it, so it's stupid on purpose kind of thing. Like it's stupid to get smarter. Yeah, whatever. Human beings learn by failure. We just learn by just getting our butts kicked. We learn by basically just failing over and over and over again, and eventually we learn. Or we learn by watching other people fail. In this case, I really don't have the wisdom of others to watch them fail, other than Dave Jones, who is one of the few that actually put himself out there, put a circuit out, and it's just very helpful for the community. So I hope that down below is a community that is more so the guys that are actually all that, just trying to spread some knowledge. That's what I'm here trying to do. I'm just trying to create that community, trying to whatever. Anyways, linear regulators. All that a linear regulator is an op amp into a BJT. In this case, it's a BJT. They have a constant current source here. I'm going to do this a little bit differently in mine, but basically, yeah, they're just saying V in, and so yeah, it just goes across and it goes down and through into the op amp and to the positive side of the op amp. So again, op amp into BJT. This one's good to 1.1 amps. That's fine. Yeah, that's the other thing. Everybody and their dog on YouTube, if you just Google YouTube or just YouTube search the just a DIY power supply, everybody and their dog just takes a module, hooks it to another module, and calls it good. In fact, I have one sitting right here. That's exactly what I did. But I wasn't really satisfied with that, so I wanted to make my own. I wanted to learn. You don't learn anything by soldering modules together. You just don't. You learn a little bit. You get some confidence. So it has its place, but there's just not a lot of people out there doing real electronics like this, where you're actually building circuits, actually trying to understand how components work, how to make things better, etc. And that's what I'm after. So yeah. Anyways, what I want to take from here, I just print off the first page of the LT3080's datasheet. It's just an op amp into a BJT. That's it, with a constant current source. That's it. It's stabilized, all that kind of stuff, so it is special in that way. But for us, this chip costs like $7 off of DigiKey. It's like $5 off of AliExpress, and you wait 3 months. It's kind of a lot. It's not really a chip that you would use for anything else other than this. It's just an expensive chip. So then, well, we could go the route of the LM317. Much cheaper chip. It's pretty good. It does have, like Dave Jones explains in his videos, that 1.2 volts minimum voltage. It's a little high, but whatever. That would work too. It doesn't really matter. That would work too. For my purposes, again, the decisions that I'm making are not based on what's the best circuit or what's needed. It's more so, how am I going to learn the most? And so for that, I built my own linear regulator. This is a circuit. Hopefully you can see that. So here's the circuit. We have our op amp into a MOSFET. I used a MOSFET instead of a BJT. Here they use a BJT. I don't have any BJTs that big to carry at least an amp. I just got whatever I have in my kits. So don't have anything for a BJT that big. Have to special order it. At that point, I might as well just use an LT3080. Again, I'm trying to learn something, so whatever. I chose these parts because they are the most jelly bean parts. An IRLZ 44N is the most jelly bean MOSFET out there, and I think that just because of Great Scott, but you know, I can learn what I learn off of YouTube because that's where the resource is. I don't have money for a whole schooling just for my hobby. So Great Scott, he suggests the IRLZ 44N. That's what I got around. I got a couple other MOSFETs. They all work. I even pulled out some MOSFETs from another board, a deal that I'd taken apart, and an LM358. It's just said these two parts are dirt cheap off of AliExpress. You order a ton of them once, and then you have them around for a year or two. Then you order some more. If you use them a bunch, order them a little sooner, whatever. You have these on hand as a hobbyist, is what I'm saying. These are the two chips, like the absolute bare bones minimum chips that you have around as a hobbyist. You also have resistors. You also have some capacitors. It's a bare bones. You have this stuff laying around. You can make this circuit if you're a hobbyist. So, anyways, that being said, that's why I chose these two. Ah, shoot, these aren't 1Ks. I believe this is 150K and 20K. Probably. No, this is 20K. This is 120K, I believe. I'll have to check that when I take it apart, but anyways. This is just a voltage divider that feeds back into here. This voltage adjust will be a 0 to 5 volt signal. We're not using the other op amp inside the LM358, so it's just chilling. I put in an output capacitor here just because I feel like it might be necessary. So yeah, this is a circuit. Basically, this op amp, if you remember, is going to do everything in its power to keep the inverting and non-inverting inputs the same. So it's going to do whatever it does to keep that, and we have this voltage divider here to put it into the range of 0 to 5 volts. I believe this is 0 to like 20 some volts, but it doesn't quite end up being like that because the LM358, one of the issues is that's not a rail-to-rail op amp. It's not going to be able to get all the way up to VCC, and it's not going to be able to get all the way down to ground. So again, we just kind of wrapped it around this MOSFET with a voltage divider coming back to the inverting input of the op amp, and the non-inverting input is where we have our 0 to 5 volt signal. So that's the circuit. I just so happen to have built up such a circuit. Alright, here's the circuit right here. I have got a external 5-volt source. Now here's where calling on the actually experienced people. I don't even know where I put it, but I tried a 7805, and for whatever reason, whenever I put a load on it, and this is a constant current load, so maybe that's doing it, I don't know, something with the grounds, I don't know. But whenever I put a load on it, the voltage of this just tanks. It drops down to like 3 volts, and then obviously my output tanks because it was having 5 volts, now it's maintaining 3. So the output tanks, and then, yeah. Anyways, if you know why that happens, let me know, because the input voltage is still like 19-20 volts. It's just strange. So I have an external source coming in on this old USB cable, DuPont wires. If you don't have a crimper and you're a hobbyist, get one. They're cheap and they're awesome. So anyways, we got it all set up. Let's do it. We're gonna go ahead and kick it on. Boy, that didn't sound good. Anyways, we're gonna go here. We're gonna set this to start at 100 milliamps. I'm just gonna walk it up. I don't really care what it is at. The yellow is the output of the circuit. This is the signal of the circuit. So you can kind of see down here the blue and the output there. So let's set this to a voltage. In my case, I think I'm just gonna set it to about 10. Oh wow, that turned out really well. And then you see my control circuit is at 1.9697. Oh, it's jumping around a little bit. That is coming out of the potentiometer. So now, what I'll do is I'll just slowly step through my constant current load. Oh, we're off right now. Set it to 100 milliamps. Go ahead and kick it on. And we're just going to slowly walk through it. And you'll see, hopefully, that neither one of those two numbers really change that much. We're at 300 milliamps, 400 milliamps, 600 milliamps, 1.1 amps. Kind of jumping around a little bit there, weren't we? Maybe that's where that output cap comes in. So that is 1.2 amps. That's about as high as I go. Yeah, that's as high as my constant current load will go. It's 1.2 amps. Let's go ahead and shock it once here. Does it move at all when we hit it? Yeah, it moves a little bit. So let's kind of bring that back down. So like I said, we just stepped it through 0 to 1.2 amps. Alright, after roughly 5 minutes of running, we are at about 115, 110-ish. Sorry, 9.8. We went down just a little bit, maybe with the heat. So something to keep in mind. Also, I didn't mention this is at 19 volts going into the whole circuit. I also didn't mention that we can go down to 1.7, 1.8 volts. And then at the very top, I can go up to about 16 volts. You could mess around with the 2 resistor values. I have not tried it with the output capacitor. But this is getting drawn out enough. 19 volts. You know, I could bump that up. I think the LM358 is good to like 32-ish. I'd have to look at the data sheet. But around the 30 volt mark. I don't really need to get that close to it, so I probably won't. But so there you have it, a linear regulator. One last thing, I thought I would test this circuit with these. They are P90, P80, NF102s. I pulled these out of a UPS, I believe, that I'd taken apart. So I thought I'd do the same thing here. You get 1.1 volts, 12, 13 volts. Not bad. So it still works with this. Oh boy. That escalated quickly. Oh man. Anyways, works with jelly bean parts that you pull out of old crap too. See you next time.